on. If you were here earlier, you already kind of know what the list is. The first thing I'm going to show you is how do you calculate what you need to do to get in the final to get whatever grade you've got. Now, I sent out an email today with the up-to-date score that you've got. So if you've got that email, what you need to do is you need to find what your total percentage is. So let's just pretend that yours is 80%. So I can show you what the calculation is going to be. So some of you it'll be 91 and some of you will be 65, but whatever the percentage is, that's the number that you need to find. The other numbers don't matter right now. That's the key number that does. Now, this number can be changed a little bit. If you do all the homework that's left and you do really good and you turn up, well, you have, so you're here today, and your participation grade is high, then that might go up to 81, maybe 82, but that's what it will. If you haven't done any of the homework, that could drop down to 60, maybe 65 or even 70, right? So I'm basing that on, that's what I know right now, and that can change depending on what you do over the next few days. So the first thing you're going to do is you're going to find 80% of 700 points, or whatever your percentage is. So if you know what your percentage is, you'll do 80%. If you want to know in the calculator, you can do that as a 0.8 times 700. And in this case, that ends up being 560 points. And that I'm going to call your raw score. Now I'm going to build up a little table. And we're going to put in a grade of 2.0, and a grade of 3.0, and a grade of 4.0. And here I'm going to put the total points you need. So if you want to get a 2.0, the total number of points you're going to get or have to get is 750. If you want a 3.0, the total number you're going to have to get is 850. And if you want a 4.0, the total number of points you're going to have to get is 950. And in the middle is what you need to get in the final. So this is how many points you will need to get in the final to get these grades. And the way you calculate it is, take your raw score and subtract it from this number. So this person has a raw score of 560. If you take 560 away from here, you will get 90 points. So this person needs to get 90 points. Oh, and by the way, the final exam is worth 300. So you can see this person doesn't need to get that many points to pass the exam, to pass the class. And that's about 30%. Now, if you want to get a 3.0, that becomes 190 because you take this away from here and it's 190 points, which is about, oh, what's that? It's about 63, 64%. That's certainly doable. And then you would need to get 290 points to get a 4.0. Now, I'm not saying that's not possible, because it is, and people will do it, especially if you do all your homework and you bump this grade up a couple of percent, then that becomes a little bit more realistic. Now, these are not the only grades you can get. You know, you can get a 3.2 and a 3.5 and a 3.8 and all the other ones. So all you need to do is basically, for every 10 points, this will move 0.1 of a grade. So if you got 200 in the final, it would be a 3.1. If you get 210 in the final, this would be a 3.2. So that's how you're going to calculate what you need to get whatever it is your goal is in the final. Now, here's something you might or might not know. 2.0 is normally a passing grade, and it is here as well. But because statistics is a terminal class, and if you're not going to use it for anything else, like you're not going to use it for your nursing program, or you're not going to use it to try and go to university and take the next level up. If all you're using it for, so it's a big proviso, is the numerical box that you tick to get your associate's degree, you can actually get a 0.7 and it will still qualify you. Did you know that? That for a terminal math or any terminal class, a 0.7 is what you need. So in this case, this person is going to get it because the total number of points that you need to get this guy is 620 points. So let me check that. 620. I think I made a mistake in my calculations here, didn't I?
Mm-hmm.
I did. I apologize. I took 560 away from that. That's 100. That's 200. And that ain't going to happen. Okay, that's better. There. I hope you did better subtractions than I did. Moral of that story is use a calculator. Right. So that person, their goal is a 3.0. It's doable. They're not going to get a 4.0. There's not enough points left for you to achieve that. Now that I've fixed the totals, is there a question about this that you're not sure about? You take your raw score away from these numbers, and that's what you need to get in the final exam to get whatever grade.
Did you already add in on the assignments? I didn't see it in there, but did you already add if we did that 2% extra credit? Is that already added?
All the extra credits are in. Yeah, they're in. So the only thing that isn't kind of finalized is your homework grades and your participation grades, because I only did up to week 9. So I, sometime over the weekend I'll put in week 10, and I'll also be putting in once the homework is deadline is finished, I'll be putting in what your final homework grade is. So hopefully you're doing well with those numbers and you're keeping them nice and high, just so that might move up a couple of percent. Are we good with how to calculate what you need then to get whatever grade you're interested in statistics? I'm waiting for a question, and if I don't, I'll move on.
I want to know where the base grade is. Where did you say it was going to be at?
What do you mean by the base?
Or
base rate?
How am I supposed to get like the 80% or whatever percent?
Oh, when you will look at your letter that I sent you, and it will say things like, Taryn, you've got 82%.
Oh,
You know the letter that I sent, that one?
Yeah, okay.
Towards the bottom, I've got a grade, like a 2.9, and then above it, I've got a percentage. That's the guy you're looking for. Can you see the guy I'm talking about?
I think so, I'm looking. But yeah, I'm pretty sure.
Looking. But you know where it is if you find it. So for different people, that'll be different. Some of you, that's 95%. Do you know if that's 95%, these numbers change quite a lot, and it becomes much more realistic that you might get, a pass and a 3.0 or a 4.0. They're much more achievable if your grade right now is bigger. And if your grade is less, you can still pass. I think everybody, with a couple of exceptions, can still pass. But you have to do well in your final, so make sure you're ready for it. Okay, let's move on to topic 2 then. And we're going to do a review, which is basically, hopefully you'll have lots of good questions for me. Let's just make sure that everybody is clear about when the final is. It's a week today. So I will not see you again. This is our last visit. If you want some help, you're going to have to just email me and we'll do some kind of arrangement for a special Zoom meeting perhaps. But this is essentially the last class day for us. Next week, there is no classes, except if you've got a Monday class, that will be your English class will still probably run on Monday. But Tuesday to Friday is exam week. So the only classes you should be taking next week are final exams in whatever classes you have. So ours is going to be on a Thursday, and it's going to be from 1 to 4. And the questions are going to be in the form of a Canvas PDF. So when you turn up, you'll go to Canvas, there'll be a link that says final exam, you'll click on it and open it up, and you'll do the questions. And it's going to consist of, to remind you, 10 multiple choice, 10 points each, that's 100 points. And then a section 2, which has 10 questions in it, and they're worth 200. Now, for those who were here on Tuesday, I mentioned this. Do I want to or even need to see working for the multiple choice?
No.
No. All you will tell me is 1 is A and 2 is B. And Charlotte, if you don't know the answer, what do you do?
It's surely out.
Right? You're doing the military, pick a C, or you don't like C, pick D because it's your favourite letter. You're going for C if you know. What is that true, or is that just a urban legend that in the military, if you pick C, you'll pass every exam?
Oh no! Oh no! It's true. You won't pass very well, but you will pass.
Okay. So, and if you join the military, there's a piece of advice: just hit C when you don't.
I got a better piece of advice: don't join the military.
So that is definitely, from your perspective, a good piece of advice, I'm sure. I don't want to make people not join the military because I kind of like the fact that we have military. I wouldn't want to be in a country that didn't have it. I suspect Russia and China wouldn't be that nice if we didn't have a military, because they do, and I don't see them banning it.
Make no mistake, I did a lot of good in my career, but after 20 years of doing something, I'm just tired.
You've had enough.
Yes.
I totally, I appreciate your service. I really do. 20 years is a long time in any job, but especially in the military because it's so tough on your body, isn't it?
Knees, back, neck.
It just wears you out. Yeah, I hear you. Okay, so section 2, on the other hand, show me every piece of working you possibly can think of so I can give you partial credit. Also, every question that you get that's to do with finances, that's these guys up here, you will get the formula that I want you to use in the question. So your job is not to try and figure out or guess what formula you need for each story. So if it's a mortgage question, I'll be doing the amortization formula. If it's Johnny saving up for Christmas, then I might do compound interest formula, whatever it might be. Excuse me. But that's the only formula you get. Most things are not formulas anyway after that, right? They're a lot of calculator work, but they're not formulas. I'll put that out the way. Here's a list of topics. Is there any topic you would like me to do something on? It can be a specific question or just a general. Can we do stuff on kind of thing?
Could we review amortization?
Yes, right. So okay, if you bear with me for a few moments, I'm going to see if I can find a question on WebAssign Because if I make up my own questions, you end up with really stupid answers. And I'd prefer not to choose a question where you end up with, you know, weird results that don't actually exist. So I'm just taking a few seconds. It's 11:06. Guess I should give you a number. So if you want to go back and, oh, that's a question. I think I may not have done that. Have I set up WebAssign so you can go back and look at your earlier work? Is it at least viewable? Please tell me it is. I can't tell looking at mine because it doesn't work that way. But while I'm getting this set up, if someone could check that you can actually look back and see the stuff that you've done before.
You can. If you go to past
Oh,
assignments.
Okay, good. That's what I wanted. No. I'm just trying to find a question. Okay, I'll just pick one then. In amortization 1, the formula is P equals M. And then it's, well, I'm doing it the way they've written it. 1 take away 1 plus R over N to the power of negative NT. And then on the bottom, they have an R over N, and then they finish the brackets like that. Make that go away now. Make that go away. So I guess we need a story for this. Let's assume that you're saving up for retirement and you put away $120 a month, right? So it's not that difficult to do. You can go to a bank and you can just ask them to set up a direct debit, and they take 120. And if you don't have a company pension, you can actually go to companies that deal with annuities. Basically, they're like banks very often, and you set up a contract with them and you give them 120 a month, and they have various investment strategies that try and make you money out of it. Now, the number N is the number of payments you make a year, and that's very typically 12. What does R stand for in a typical story like this?
Rate.
Although you get the formula, yes, the interest rate. Now, normally you get the interest rate, it's written as a percentage, but that's not the value of R we use, is it? Don't you always use the decimal version of that number? And T, I think, is pretty easy. Isn't T time? And typically in these kind of questions, it's time in form of years, right? So we've got basically the formula you're going to use, which you would get from me anyway. There'd be a story. So I would want to see that written down quite clearly. These are the numbers I'm going to use for M, for N, for R, and T. P is going to be, typically it stands for principal. In this story, it's going to represent the amount of money that you would acquire during that time. So you're putting away $120. You're doing it for 12 monthly payments at this interest rate. And let's say, oh, Charlotte, you were in the military for 20 years. So let's pretend that when you joined the military, you were a lot more sensible than most people are. And you decided you were going to put $120 away a month because you know in 20 years, that's as much as you can handle. And you want some money at the end to live off, right? So let's see how much you can put together using this formula. So you tell me what you tell me the numbers that you're going to use. That's just in case, because I know it happens. I've done it. Do you know that you read the question and it says 3.5, but don't you end up writing 5.3 because of the nerves and so on? Well, if I look at that and I can, she or he, right? Charlotte's, she put down the wrong number. Hey, I'm not going to wallop you with a lot of lost points. I'm going to say I'll take a point off if you can't read, right? Now, P equals 120 brackets 1 take away 1 plus 0.035 divided by 12 to the power of negative 12 times 20 all over 0.035 divided by 12. Now, when I look at that question, it would scare any normal human being to death. I wouldn't even attempt to do that in a calculator in one go, because I bet you I'd screw up. Would most of you probably screw up as well? So what I would suggest strongly that you do is just leave that guy alone. Find what that guy is, write the answer here. Find out what that guy is, and write the answer here. And then once I find these three, then I do one more calculation to get the answer. And I think if I do it in that form, I'm less likely to screw up. So here goes. 1, subtract, a bracket, 1 plus 0.035 divided by 12, close the brackets, raised to the power, a negative, that's 240. I'll do that in my head. Now, we've talked about this before, but it's happened again. I need negative 240. Do I hit the white button or the grey button? Which one of them's a negative? The white button, that one there, or the grey button, this one here?
White button.
Right, negative 120. Enter. And I am looking at 120. Oh, wait a minute. I didn't need to write that. I've written it up here. 0.29495. Do you get bored? Right. Now this guy, 0.035 divided by 12. And that guy gives me 0.002917. Now I've got a relatively simple calculation with really ugly decimals. So then I do the 120 times 0.294953 divided by 0.002917, hit enter, and I am looking at 121.33 and 88 cents. So $12,133. Yeah, I was hoping for more money. What did I do wrong? Let me check something.
Yeah, I started to say that's about what I make in retirement for 1 year.
Yeah.
Yeah, 240.
Oh.
That's what it was.
Yeah. That looks a little bit different than the first time I did it. Do you see that? So 0.502908. Try the other one. 0.035 divided by 12. No, that's good. Okay. So 120 times 0.502908 divided by 0.002917. Okay, a little bit better. $20,688.71. I'm rather disappointed. Huh? That is rather sad. No, it is what it is. I should have picked one of their questions instead of making up my own. Do you see the moral of that story is use theirs, because then you get really nice numbers instead of kind of disappointing numbers, because what you should have got there should have been a lot larger. And I think it was me maybe writing down the formula slightly wrongly. That's always possible. Essentially, what you should get from that type of question is if you use the formula correctly, you will get the right answer. So I've got a little thing I want to try here. I want to double check it before I say it. I never find things when I want them. That's not the right page. I'm having window issues. Oh, finally got you. Okay. I'm loading up the ebook right now. Well, that's a bit. And I'll move it over here. I don't know how much use you've done using the textbook, but one of the things that is definitely helpful is that you can actually find formulas. It's my goal anyway. Right. So are you looking at the Nature of Mathematics 13th edition? Is that the one?
Yep.
Right. So I'm looking for chapter 11, finance. And I want to find, if I can I do it here? Yes, I can. And the one that we were trying to do, or I was trying to do, was amortization and monthly payments. Nice little video. There's that formula. And this guy here, which I'm now writing down, M equals P R over N. And on the bottom, it's 1 take away 1 plus R over N to the power of negative NT. It's just a rearrangement of essentially the other formula. This one tells you M in terms of P, the other one told you P in terms of M. Just fine, I guess. And this one is the mortgage one, which I like. So I'm going to use that formula now that I've got it to do a mortgage story. So it would be nice, but no guarantees here, that we get the monthly payments when you borrow P dollars at an interest rate of N for 12 months. So does anybody here want to share their sisters or their next door neighbors' mortgage information? If not, I guess I'm just gonna have to guess. Does anybody know it? So that when I get the number, you can say, yeah, that's pretty much what they pay. Otherwise, I'm just making one up again. Anybody want to share that? It's kind of sensitive, so I understand why you don't know it. Okay. Do you know that the housing market is booming right now? So, Karen, you're going to buy a house. Tell me how much you want to spend on it. Total fictitious.
All right. Let's say it's 400,000.
Right.
You pay over
So-
30 years,
Okay.
and your interest rate right now would probably be like 2.6.
Yeah, you can get this is like
Oh, yeah?
weird numbers. It's like exceptionally historical. I don't know when the last time it was even close to that. That's how. I think that's one of the reasons the market is booming, because the interest rate is so low.
Wow.
You can actually afford.
What is it going for right now?
No, that is pretty much it. I think it may be,
Oh
it
yeah,
depends
that's what
on
I
if
thought. I
it's
was like, I
20.
think that's
Yeah.
what it is
No, I'm
right
just saying
now.
that is realistic, but it's
Yeah.
historically tiny. I mean, and
Yeah, no, it's not 10
I've
years
lived
ago.
through I've lived through double-digit mortgage rates. Do you know that they had 11 and 12% mortgage rates
Wow.
in
Oh,
the lifetime of me? So that's how small that is. So that's 0.026. Number of payments is monthly. I don't think anybody's going to do that. And we're doing a 30-year mortgage. So I'm setting up my same guy. I'm pretty comfortable that these numbers kind of make sense, right? If you went looking for a house, I think 400,000 is reasonable. I'm sure you can get cheaper, but you can also get more expensive. The mortgage payment, M, is going to be 400,000, 0.026 divided by 12. And on the bottom, it's 1 takeaway, 1 plus 0.026 divided by 12 raised to the power of negative that guy times that guy. So I'm just going to do that like that because I think I may have hit the wrong button the last time. So I'm going to find the top, then I'm going to find the bottom, and then I'll get the final answer. I'm guesstimating about $2,000 a month. Right. So if it ends up being $40 a month, I've screwed up. And if it ends up being $20,000 a month mortgage, I know I've screwed up, right? So 400,000 multiplied by 0.026 divided by 12. And the top number is 866 with lots of sixes. The bottom one is 1 takeaway bracket 1 plus 0.026 divided by 12, close the brackets, raised to the power, I'll put a bracket around it this time, negative 360. And on the bottom, I'm looking at 0.541207. So I'm going to take the top number, 866, with lots of sixes, and divide it by 0.541207. And the answer I get is about $1,601.36. Hey, no, pretty good guess. I said about 2,000. Okay, a little bit shy of that. But I don't know what some of you are paying for rent, but do you know if you have good credit and a work history so they know that you're making money? That's only part of what you have to pay. You realize that isn't everything. Right? What are the other expenses? Well, you have to do a thing called escrow if you're interested. And in escrow, you typically have to pay insurance. What else do you have to pay in escrow typically? House insurance, and most of them, property tax. So that gets added in. So as far as we're concerned, that's the only answer you need. But if you want to do something realistically, you'd add these two into the mix. So property tax, let's say it's 4,800. So that adds what, another 400 a month, right? Because you do it in 12 equal payments. And property, that's property tax. Insurance, God, what does my insurance cost me? I honestly don't know. Can we pretend that I did know and it's 200 a month insurance? So what you would then do is add another $600 and your mortgage payment would be $2,201.36. So if you can afford something like $2,200 a month, you could be living in a $400,000 house. Well, sort of. Charlotte could, because she's military and she ex-military and she gets, don't you get a, oh God, I've forgotten, is it a VA bill? Can't you get special VA loans? Charlotte, are you still with us? Karen, you got military in your family?
Yeah,
Isn't there a VA loan which allows you to get 0 down deposits?
that's correct.
Right. So what you could actually get that house without any deposit.
You shouldn't do that
or
though.
Audrey, probably not. It's a different thing, but probably not. But me and Aubrey, we'd have to put down somewhere typically between 10 and 20% would be what you would need. So you would need to fork out, 40 to 80,000 from somewhere. So you're saying that like you did it once and it was a bad idea, or have you just heard horror stories about not doing a full 100% mortgage?
I just read a lot of finance books for fun.
Right. And they say not a good idea.
Yeah.
Okay, I wouldn't argue with that. And people make more money than I do, and that's their job. So if they give good advice, should certainly do that. So these count as amortization ones. The mortgage one I like. I'm sure the number's right. I'm not sure what I screwed up with the first one. It might have simply just been I hit the wrong button on my calculator. But as long
Looks
as you
right
hit
to me. The whatever you just did, what you did right there.
Okay. Oh, this one here I'm pretty comfortable with. It was the previous one to that I wasn't so sure about. But that's how amortization questions work. What I was saying is that when you do the test questions, since you're told that, isn't it really a plug and chug question then? Right, that's going to be in the question, right? I'm telling you, use this one. You just have to figure out who the numbers are in the story. Make a very sensible list of who they are. Put them in so I can look at this and can say, yeah, she knows that goes here and she knows that goes there. I would break it into smaller chunks because it's easier to do smaller things correctly than trying to do too much. And then your answer, and you're good to go. Okay, I hope that helped. Amortize. Oh, goodness, sugar and spices. That took a lot longer than I thought. I'm just looking at my watch, but that's fine. It was a good question. Okay, where are we off to next? Here's our list. You know that although the final will have everything, the final will have more from the second half than from the first because you've already done a midterm, so you're not going to get a 50-50 split. I mean, I'll pick a topic if you prefer, but I'd rather I was doing something you were interested in.
I thought your study guide was fantastic. Maybe pick some stuff from there.
Oh, you like that one?
Yeah.
Okay, I will zoom back on that guy. And I'll close this window. Okay, I'm confused. I can't get rid of you. Yeah, Zoom was doing that this morning. It was just being really weird. Right, close it off. Gotcha. Got something in chat. Maybe someone asked for a question in chat. Oh, no. Question is, it's an open book, all chapters by open book. Yep. If you've got it written down, you can use it. But will you remember that everything will be cut off? There'll be nothing on WebAssign for you to look at. So you won't be able to look at the ebook there because it won't be there anymore. So make sure you make lots of good notes, right? Write down everything that is helpful. And Nadia's asking about the voting one. Yeah, voting counts. It's one of the topics. You could get a question on it. There wasn't an awful lot in the voting section.
I have tried.
So don't expect big points.
And I didn't do anything about it.
I missed the beginning. What did you say that you didn't do anything about?
I tried to do homework with voting questions and I couldn't do that. All of them.
Okay. Well, I'll do I'll look up the practice one and then straight after that we'll go and we'll look at the homework and voting and maybe I'll give you some clues on it because if you can't, I'm sure there's other people who had issues with it as well. And sometimes it's just what they want you to do. Once you understand that, it's not that hard. It's a very short section as well. Okay, so I'm clicking on practice final. Even if you can't see it, I will have it up and running in a few moments. And here we go, I hope. You should be looking at my study guide, right? That fella. Is there any topic within that that you would you wondered, you know, why the answer is C and not the others, or just zoom through it? And anything that comes to mind as I'm going through that you want me to look at?
Could you do some of the probability ones, please?
Sure. Do some of those. Right, so I'm going to do some probability ones, and we'll look at Nadia's thing after that, I think. Okay, so I guess I really need to kick out of here. And back in.
Yeah.
Right. Now, the context of probability, the stories that you get, they tend to be things to do with cards, right? Dice. And bags with beads in them. Right. That's just the storyline. So let's do cards. Start off with the simplest one, just to get us warmed up. If I ask you to find what's the probability that you take one card from a deck of cards and you get a king, you have to know that a deck of cards has 52 cards in them and that there are 4 kings. And as a fraction, the answer is 1 over 13. And if they want the answer, if I ask for the answer as a decimal, hopefully I will say something like to 2 decimal places, in which case it's 0.08 if you round it up. So that's the probability of you getting a king. You could also be asked things that require a little bit more counting. What's the probability that it's a red card? So you have to know a little bit about the 52 cards. They are called hearts, clubs, diamonds, and spades. Hearts is red and diamonds is red. Clubs are black and spades are black. And there are 13 of each of these different suits. So that's 26 are red, and that becomes a half. What is a decimal 0.5? But then you get questions that are called conditional probabilities. And you might be asked to find what's the probability that you get a red card given that it's a king. Now, whatever piece of information you are told you are given, that becomes the new bottom number. So if I tell you that you've got a king, you will immediately realize that that makes the bottom number 4. And the world now just consists of those 4 kings. If I write them down, there's a king of diamonds, a king of clubs, king of hearts, and a king of spades. And now when it says red card, I'm only looking at these 4 kings and I'm saying you're red and you're red. So that's where the 2 comes from. And that becomes 0.5. If I do a more complicated version of that one, what's the probability that you get a king given that it is a face card? Does anybody know what cards are called face cards?
It's a
The
queen.
ones that are the suit of Jack, King, or Queen, they have faces on them.
That's the ones. So Jack, Queens, or Kings. So if I say it's a face card, if you had a deck of cards and you put all the kings and the jacks and the queens out, wouldn't you have 3 of them from the hearts, 3 from the clubs, 3 from the diamonds, and 3 from the spades? Do you see that that now becomes 12? Right. So I'll have a jack, queen, king of clubs, a jack, queen, king of diamonds, jack, queen, king of hearts, and a jack, queen, king of spades. Of all these cards, which ones of them are kings? Well, 1, 2, 3, 4. And 4 out of 12 is a third, which is about 0.33. Now, if you take a probability and you switch the information round, you do not get the same answer. In fact, it's very rare to get the same answer. What's the probability that you get a face card given that it was a king? Well, I know that there are 4 kings. King of clubs, king of spades, king of diamonds, and king of hearts. How many of those 4 cards are face cards? It's almost a silly question. How many of these 4 cards are face cards?
4.
And so in this case, do you see that the answer is 100%? Now, there is a thing in probability called independent events. And there's a test for independent events. And it says, if the probability of A given B is the same thing as the probability of A, then we say that A and B are independent. Now, what's the probability that you get a king given that it's a red card? Okay. How many red cards are there in a deck of cards? Count them up. How many red cards are in a deck of cards?
It's half of the deck, so
26. Agreed. Now, those 26 red cards, how many of those 26 red cards are kings?
2.
2.
And that simplifies down to 1/13. Now I'm going to find the probability they get a king, right? Just a king, no other information. Well, there are 52 cards in the deck, 4 of them are kings, and do you notice that the answers are the same? This is like A given B, and this is A. And if these 2 distinct probabilities are the same, we can say that a king and the red cards, so getting a king or getting a red card, are independent of each other. You're just as likely to get a king that's a red card as not a red card. I guess that's one way of saying it.
Independent.
Now, and or, they're quite weird. What's the probability that you get a king or a red card? Well, the bottom is 52. You're only picking one card out of deck, and we want to know the probability that it's a king or a red card. I know that there are 4 kings, right? King of hearts, king of diamonds, 4 kings. I know that there are 26 red cards, but the answer isn't 30 over 52.
You have to minus the other two out. On the 4
Yep.
kings, there's only 2 that are red.
Yeah. So I call that you don't double dip, right? You don't count the same guy twice. So the -2 copes with that. And so really the correct answer, if I just leave it as a fraction, it's 20 over 52, and you can turn it into a decimal there. So do you notice that when you do ORs, you have to be quite careful about counting and making sure you don't count the same card in 2 different places. And that's the thing I call double dipping. Now, what about an and then? Well, when you say in probability, what's the probability you get a king and a red card? And another way of phrasing that would probably be better to say both. What I mean by that is, how many red kings are there? Right? It has to be both things. Well, there are 52 cards in a deck, but how many of them are red kings? They're both things. And do you see in this case, the answer then would become that. So ORs and ANDs are quite different things, aren't they? Probability of something or something against the probability of an AND. Is there any other questions in probability that you want me to do before I kind of leave this and have a look at Nadia's questions on voting? Okay, if we are good, then I'm going to move on. Just close this thing off for the time being. And now I have to go hunting for the window.
To be clear, when I doing those questions, it's not clear.
Are we talking about the voting questions, Nadia?
And about probability also.
So if I pick you up right, what I just did here is clear, but when you then go and look at homework questions and things, you're not so sure anymore. And I guess the only advice I can give in those kind of situations is that you have to practice makes perfect. If you do enough examples of them and keep doing examples and read the book question and look at solutions that I've done and so on, then hopefully you'll get enough experience where you'll feel comfortable about those questions. There's no substitution, unfortunately, for hard work, right? The more practice you do, the better we can become. Okay, I think I'm ready. Let's have a look at the voting section, and we'll see what's going on here. Are we looking at, I'll take that out of the way because that's a distraction. Okay, are we looking at voting, chapter 17? Is that what you can see in the screen? I need kind of help here.
Any of it.
Ah, well.
Any.
Okay, so we are seeing it, Nadia. So what we're looking at here first is the way in which they discuss some voting. So in this question 1, there are 3 candidates, right? 3 people who want to get elected. And these candidates are called A, B, and C. Right? And in this voting system, you don't just vote for the guy you like, you put them in order of who you like. So in this first case, A, B, C just means I like A best, B is my second choice, and I really don't like C at all. And this one at the end, this is, I like C, that's my first choice, B is my next choice, and I don't like A. And there are 2 distinct different voting systems that they use, or that at least there's lots of them, but there's two that we're going to look at. And one of them is majority rule, and the other one, as you'll see later on, is a kind of proportional representation situation. So I'm going to write this down because it's quite short, and I'll show you how this information can be used in 3 different ways. If you can bear with me for a little while. So, in this voting question, there are 3 candidates, A, B, and C. And these are the number of people who voted this particular order. So for instance, 4 people picked C to be their first choice, A to be their second choice, and B to be the third choice. Now, the question 1 that this came from asked for one question, only asked one question. What's the total number of votes? One person, 6 people, 7 people, 5 people, 4 people, and finally 9. So the total number of votes is what you get when you add all these together. And 7, 14, 19, 23, 32 votes. So 32 people voted in this election. So I don't know, it's like a class election, right? You have a little class and you vote for who's going to be the class president. And there are only 3 candidates. And 1 kid voted for this and 6 voted for that, and so on and so forth. So the first kind of question might simply be, just tell me the total number of votes. That's it. The second one and the third one are going to be who wins. Who wins the election? First kind of voting system is the one that you're very familiar with in America. Let's go. Majority wins. So let's see how that works. This guy here was the first choice. So A gets a vote. I'll do a little list. B gets a vote, and C gets a vote. This one here, 6 people voted this combination, but 6 people voted for A. In this one, 7 people voted for B. In this one here, 5 people had B as their first choice. In this one, 4 people voted for C. And in this group, 9 people voted. And the voting splits that way. Who won this election based on the majority rules system?
It is C.
Because he got more
C
votes.
won. Majority
C
is
won.
C.
Yeah, that's who wins. So that's what if that question had been who won using majority vote, that would be it, right? If you look at that, since 32 people voted, isn't that less than half the votes, yet you still win? Isn't it true that in some states, maybe more than other states, couldn't you win the election and still not have half the votes? Can you have 3 candidates, an independent, a Republican, and a Democrat, and the independents sucked 7% of the votes away, and so the guy, could win with 42% of the vote? It could easily happen. You do not want to have a third candidate in an election if you are a politician, because couldn't that third candidate, for want of a better word, and I think it's a good word, steal some votes from you? It's not a good way to phrase it, but I can't think of a good one. Pull votes away from you. And couldn't you end up losing the election? Whereas if that candidate hadn't taken part, couldn't all the votes he got, most of them might have came to you. So it's a dangerous game to play. If there's only two candidates, it becomes really easy, you know, Republican or Democrat. Occasionally you have a third party, but that, you know, it's like the Green Party, nobody votes for them, right? 22 people vote, doesn't make a difference. It's only if the third candidate is a biggie that it works. Now, there is a majority vote, and that's what that one is called. And then there is a ranking system. And they have different names on them. I'm trying to find out what name they've got in this so I can use the same name, but it's called the border count. There we are. And let's show you how the border count works. Each vote and the order that you voted for matters. So you give first choice 3 points, second choice 2 points, and last 1 point. Okay. 3 points, 2 points, 1. 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 Now, this system is a lot more complicated. So it's not as easy as a majority rules, because in majority rules, basically, when it was paper votes, didn't they have a big bucket? And the Republican votes went into the Republican bucket and the Democrat votes went into the Democrat bucket. And it was pretty easy to count, right? You just counted, you know, the two buckets and the biggest number won. Now, in this new border system, you take not just the number of people who voted, but the number of points you would get in each situation. So let's take A again. This is candidate B and candidate C. I'll start with candidate A. In this combination, one person voted and you get 3 points for it. So that's one person, 3 votes. In this group, 6 people voted this combination and 6 people, A got 3 points, so 6 people with 3 points. In this group here, you get 2 points and 7 people voted it. In this one here, last choice gets a point. 5 people voted this combination, so it's 5 times 1. This combination, you were second place, so you get 2 votes, 2 points, I should say. 4 people voted, so that's 4 people with 2 points you get. And lastly, 9 people, and you were the last choice as 1. Do you see how much more complicated it is now to see the number of points you get? So you're not getting votes directly. What you're getting are points. And the person who gets the biggest points wins the election. Let's see how that works. D, add 18, add 14, add 5, add 8, add 9. So that's 21, 35, 40, 57 points. So A got 57 points. Do you think A is going to win the election? I haven't done the other 2 yet. Do you think A is going to win? Any gut feelings? Don't know yet? Okay, let's move on to B then. Start at the beginning. One person voted this, so there's one person with 2 points, 6 people with 1 point, 7 people, 3 points, 5 people, 3 points, 4 people, 1 point, 9 people, 2 points. Does that become 1, add 6, add 21, add 15, add 4, add 18. 7, 28, 38, 43, 47, 57, 65. So B got 65 points. So right now, isn't B winning the election? Right, he's got more points than A. It's all about points now, rather than just, you know, votes. It's the points associated with. So let's see if C wins the election. 1 at 1. 6 people, 2 points. 7 people, 1 point. 5 people, 2 points. 4 people, 3 points. And 9 people, 3 points. So you're going to get 1, add 12, add 7, add 10, add 12, and finally add 27. 13, 20, 30, 42, 52, 62, 69. So using this border system, didn't C win the election? Right, the person with the greatest number of points wins the election. There are a huge, huge number of different voting techniques. There is, for instance, a variation on the border system. Suppose you have an election with 3 candidates. You don't have an election with a decider. You have 2 elections. What you do is you have 1 election like this, and then that person drops out. He's kicked out the competition. You then have a second, a final election, where it's 2 people, one against the other. And in the second election, you don't need to do all this border stuff. Don't you just do majority rule, because it's 2 candidates. So you can see you can have a kind of 2-tier system where you use a point system first, just to eliminate the least desirable candidate. And then from the 2 candidates are left, you then have a face-off 1-to-1. From the 2 techniques, do you have any preference? Do you think one is fairer, whatever fairer means? Do you think majority rule is fair enough? It's a good way of doing it? Nothing wrong with changing it. There's no reason to keep it or to change it. It's what we are happy with. If we like it, we should keep it. And if we think it's unfair, then you should change it. Is that helping you a little bit, Nadia, with the point system and how you count these things? Because there's a lot of questions in that are pretty much just like what I just said.
Yes, it's helping a little bit.
Okay,
So
give me another question and we'll do one more and we'll have to move on after that. So if you have a specific question from that list that you want me to do.
what about number 2 question? It's it says,
okay,
if a person ranks A as their first choice, C as their second choice, and B last, how would this be written? I cannot understand. And how many voters have this preference?
Okay, so it might just be a language thing. In this question, then, I'll zoom over to it and I'll just say the answer. Yeah. I don't know where we're. Come, stop fighting me. Zoom's fighting me. Stop doing that. Okay. So the question you're talking about is this one here, or at least a version of it.
Yes, this one.
Right. So if a person ranks B as their first choice, C is their second choice, and A is their last choice, how would that be written? That would be written as a B, a C, and an A. That's all. So I'm wondering if it's the ranks is the thing. The word ranks was kind of confusing you to what the meaning was. That's all it would mean.
Okay, and how many voters have this preference? Just
How
two
many
okay,
people?
5.
Right. So do you see this guy up here in my question anyway has 7? That was 7 people voted the same way as B, then C, then A. And I know it's 7 because in my question, at least, right underneath,
I said it's 5.
oh, BC, I take it back. I scanned to the wrong number. It's 5. So
Okay.
that would be it. Now, if you did the border count on that, wouldn't you call first place 3 points, second place 2 points, third place 1 point, and you do that big long calculation, and you'd end up with a winner, hopefully. And the winner would be the person with the greatest number of points. And if you were going to do majority rules using this data, wouldn't you just count how many people were picked first in each of the 3, A, B, and C? And the person who had more people voting them as their first choice would be the majority rules winner. And they aren't always the same. You can have a majority rule gives candidate A as a winner. And if you do this point system, candidate B might be the winner, right?
Mhm.
I'm not sure how you interpret that, except to say the way that you decide to do voting, as long as everybody knows before the election that that's how votes are going to be counted and that's how you're going to decide a winner, I don't think you have anything to complain about. I would be really very annoyed if I was a politician if they had an election and then they waited to after the election and they went and said, I don't like the result. Let's do a border count technique instead, because I want candidate B to win. You can see that that would be cheating, wouldn't it? You got to decide before the election, we're going to do it this way, right? Majority rules, border count, whatever it's going to be. As long as everyone is playing by the same rules, then the result is, you can't really argue about it. I don't think that's ever likely to happen, that they would change the rules, but I don't trust politicians, so who knows?
Can I ask a question,
Okay.
please?
Yes, Naja.
Question number 6. How many different ways can a voter rank 3 candidates? No ties are allowed.
Okay, that's a quick question, so let me show you how we would do that. And we do that using an idea or a technique which is called the counting method. It's just the name we give to what I'm about to do. So suppose you have 3 candidates. You don't need names for them, but I'll call them A, B, and C. So there's a first choice, a second choice, and a third choice. First choice, you can pick anybody you like. So there's 3 choices, isn't there? Now, once you've picked your first candidate, how many people can you choose as your second choice?
2.
2. Now, once you've picked those, aren't you left with whoever's left? So there's only 1 choice.
1.
I suppose, yeah. So the answer is 6. There are 6 ways in which you can choose 3 candidates. Suppose we jump to 5 candidates. 1, 2, 3, 4, and 5. Okay. First person, 5 choices. Right? There are 5 people you could pick. 5 candidates, 5 people you can pick. Now you go to the next choice, isn't there only 4 people? Great. 5, pick somebody. Now there's 4 choices. What about the next choice? How many people can you choose from when you get to your third choice? How many people are
3.
left to pick from? Okay. And then 2,
3.
and then finally 1. Do you notice there's a nice little pattern? In this case, there's 100 and I believe it's 120. Called the counting method. Is there any other questions from our list or anywhere else for that matter? Aubrey, have you got a question? It looks like you're about to hit the space bar. You do? Okay, what's your question?
It's just when I look back from my homeworks to see which ones I didn't get. It was the one, and I had trouble on the midterm too, about like with replacement, without replacement. It was calculating complex problem.
Right.
13.4. Yes.
So we have with replacement and then without. Was it the question to do with beads or was it to do with cards? Can you remember it? It doesn't really matter, but it would help if I knew. Was it questions to do with taking cards out of a deck and putting them back in, or was it to do with beads in a bag, which is the second most common storyline?
One of them was the marbles. So
Okay,
beads,
marbles in a bag. Right, so imagine you've got a bag. Here it is. Bag. How many marbles have they got? They're typically 2 colors, but there might be 3.
They have 6 red marbles and 3 black marbles.
So just to be visual, here you go. Now, let's suppose that you choose 1 marble out of that bag. Just 1 marble. The probability that that marble is black is very easy to calculate. It doesn't care about these because 1 marble doesn't care about this. There are 3 black marbles out of a total of 9 altogether. So that ends up being a third. Now, suppose you do with replacement. Now, in a story that has with replacement, you're going to take 2 beads or whatever it is, right? 2 things out the bag. But you pick the first one up, you look at its color, and you write down what its color is, and then it goes back in the bag, right? That's what with replacement looks like. So you could then be asked, what's the probability that both of them are black? Or you could be asked things like, what's the probability that the first one was red, right, and the second one was black? You know, questions like that. So how do you calculate these probabilities? One of the best ways to do it is to build a tree called a probability tree. And the first bead could be red or black. And the chances that it's red is 6 out of 9. And the chances that it's black are 3 out of 9. Because when the first bead comes out, right, you look at it, it's red or it's black. That's the chances you get red. This is the chances it's black. But then it goes back in the bag. And so you now have a second bead, which is what this piece of the tree is going to do. But because you put the bead back in the bag, the chances that the next one comes out being red is still 6 out of 9, because there's still 6 red in the bag, right? You put it back in. And the chances that it's black is still going to be 3 out of 9. And the chances that this one is red is still 6 out of 9. And the chances that this is black is 3 out of 9. So when they say, what's the probability that they're both black? You look at these 4 endpoints and you say, which one of these pathways is both of them black? And it ends up being this one. And the probability of this event happening, you multiply the roads that got you there. So the roads, the pathway is 3/9 and another 3/9. So you go 3/9 times 3/9 And that's what? 9 over 81. The answer is a 9th. Now, if they say, what's the probability that it's a red bead and then you've got a black bead? Well, a red bead and then a black bead would be this pathway. And you would do 6/9 to get the red one. And then you do 3/9 to get the black one. And that's 18 over 81, which I believe is 2/9. So from this picture, can't you answer any of these kind of, what would happen if this happened and that? And what's the probability of this particular combination coming out, right? A red and a red, 2 blacks, whatever it is you're interested in. But that's with replacement. Now it gets a little bit trickier, and the answers are going to be different now when you do without replacement. I'm going to find the same 2 probabilities. Right, the probability that they're both black, which by the way is 1/9, and the probability you get a red one then a black one, which is 2/9. So that's the answer with replacement, and I'm going to show you, you're going to get different answers now when you do without replacement. So we'll start off with the first bead. Could be red, could be black. Now, there's the bag. The chances that you get a red bead, right, is still 6 out of 9. The first bead, there is no difference. And the black one, 3 out of 9. Now the difference happens. You're going to pick the second bead. Now, you have to kind of visualize this. You've taken the first bead out and it was red. Doesn't that mean that the bag now only has 5 red and 3 black? Do you see how the bag's got a different number in it? Because when you took it out, you left it on the table. It didn't go back in the bag, right? It's kind of eaten. So the probability that you get a red one the second time out is a bit different. There's only 5 out of 8 which are red, and the other 3 out of 8 are black. You see the probability has changed now. Now, if you do this one instead, the bead that came out was black, right? It's that one, but it didn't go back in the box. Do you notice that it's got the same kind of issue? What's the chances that it's red? Well, there are 6 out of 8 of them are red, and there's only 2 out of the 8 that are black. Now, I'm going to ask the same questions. What's the chances that both are black? Well, both are black is this one, right? And it's 3/9, right? You multiply the pathway, 3/9 and 2/8. And that's 6 out of 72, and that gets me 112. Oh, look, I'll put it beside it. Notice, different answer. With replacement, there's a 1/9 chance. Without replacement, it's a 1/12 chance, right? So it's different. Now, the other one I chose was a red and a black. So a red and a black would be here. And that ends up being 6/9 times 3/8, which is 12 out of 72, which I believe is 1/6. You see the difference between a with replacement and a without replacement. But you really have to create one of these tree diagrams, probability tree diagrams, to be able to kind of keep track of all the little things that are going on here. Does that make sense, Aubrey?
Yes, sir. Thank you.
So was it constructing the tree or not realizing that you should construct a tree? Is that what was kind of
The tree helped.
getting you into trouble.
The tree, like at first when we did it, I understood, but I guess when we started taking the midterm, like I forgot, like everything just.
Well, there's so many things to remember, right? So don't be too tough on yourself. But you know, now that you've seen it, it might stick if it turns up again, right?
Yes, it's
You know,
easier
if you
than
see
I
this question
thought.
again. Right. Well, sometimes you just need a little memory jog, because as I said, there's so many things you need to know. It's quite easy if it was like 6 weeks ago and you can't, you know, you've done 20 other things since then. Kind of hard to keep all those balls juggling in the air. You're going to, you know, lose track of one of them. But how are we doing, guys? Are we covered what you want, or is there some more questions? Any? We good? And this is your chance. Why don't I do it a kind of different way? Say hi, and those who want to do more questions, just hang about and ask me. And those who've got what they needed and want to get started on their homework and getting ready for the final, you can just leave, okay? So say hi if you want to, and bye-bye. And say hi and stay behind if you want to ask more questions. That way I feel I'm not keeping you from, you know, using your time better.
Mr. Robertson, or Professor
Yes.
Robertson, excuse me.
No, Mr. Robertson works.
I'm pulling up the. Oh, okay.
I've lost
I'm
you
pulling up
again.
the.
Okay, I can see you.
Sorry,
Right.
I'm pulling up the practice final exam right now. I'll look through it really
Okay.
quickly.
Mm-hmm.
And I'll
I'm going to,
ask if I have any questions.
right, for sure. I've got it here in case you come across that. While Gabe's scanning through that, has anybody got some questions? Tara, you're very quiet. Is that a good quiet or a bad quiet?
It's a contemplative quiet. I'm just going
Okay.
through, I basically I took the whole thing and I've just been going through and doing like the blank practice test, like it
Yep.
were the test, so that I could see what I could remember and what I couldn't remember. For the most part, I'm finding everything in my notes that I didn't know, but I'm still struggling with the stuff we worked on yesterday. So I had one of them that was super weird, and it's on this paper. I made a note of it, and it was the which one was it? It was one of the newer ones with the logarithm where it has like 10. I got the first one right, but I kind of guessed at it, but then I was like, I did not get the second one right. So it's like,
could you say it out loud and I'll do it? And we can,
this one says
here can watch it.
E log and then the parentheses 100, and it came out to 739.
No, that doesn't make sense to me. Could you tell me what the question says? Because E log doesn't make sense to me.
E log doesn't make sense.
I'm not saying it's silly.
It was number 39 on the thing. That helps.
Okay. I got this.
And I
thing.
have
I can look up
similar
the
to
thing.
that on the homework. And for some reason, I don't know if I missed what I was supposed to do with it or how I was supposed to do it, but there's.
I got you now. It's e to the power of log 100, right?
Yeah.
Yeah. Okay. Let me show you what that little guy
I have a couple of them that are on the homework, and I don't know how. I know it's not complicated, but I couldn't figure it out.
This question is like a two-stage kind of question, right? So essentially, you're being asked to find the value of this. Now, there are two ways you can go about it. Let me show you the easy way.
Like the calculator.
E to the power log 100.
Oh, that's so.
And the answer is 7.38,
which rounds to 7.3. Okay, that makes sense.
Right? So all I'm doing then is I'm picking B because that's the closest. Now you might say, why didn't I put 7, 0.2 in? Well, I guess I probably should have, and maybe I meant to, but I didn't. But that's what the answer is. Now, if you wanted to do it a kind of a more complicated way,
I was gonna say I have some examples for where
I don't know what. Yeah,
on the homework. So this one
I
is
don't know what that guy is.
the yeah. You want to know what that guy is?
Yeah, well, let's see. This guy is actually log to the base 10 of 10, so I don't know who he is. So I could say 10 to the power of x is 100.
100.
And then I could figure out the x is 2. So this question now becomes e squared. Because if that's 2, then this is 2. And then I could do e squared on my calculator and get the answer 7.38 as well.
Oh, okay. Yeah, because that's what
I just thought that I'd done anything different. I just did more calculator work.
no, and
So you said there was others.
was something because I came up with it, but I was like, I don't know. I just felt like it was weird. And I have another one that is the number 2, and then same thing, it's raised to the power of log 2 x. It's super weird. I can show you if you want me to turn this around, but
Is it a number? Is it a homework
it's on
question?
a
Or is it
homework.
in
It's
this
on the
list?
homework. It's the same kind of thing though, but it's on the homework.
Okay,
C
so
and D on the homework.
right, try again and I'll write it down. Say
So
it from the
big
beginning.
number 2, just number 2, and then to the power of log. So little log, and then a little 2 next to the log and an x. And that's the homework question.
Right. Now, you cannot do that one with a calculator because there's an X there. Right?
Yes.
So
I don't even
what
know
I'm
what
going
to
to
do
do,
with it. It doesn't look like the ones that you had us breaking down before.
okay. Well, it isn't actually. But that's 2 to the log 2. Now, if you have a base and a log with the same base, they essentially cancel out, and the answer is just x.
And the answer is just x on there. There's no 2s, no nothing.
Yeah, look. Yeah, I can show you an example. E, the log to the base e of 7.
Well, holy
Ends up
snarky,
being
that's
7.
totally right. I would not have
And
gotten.
so 2 to the log 2 of x gets you x. And what that's basically saying is, do you know that these two like cancel each other out? It's a bit like somebody saying to the square root of 5 square, shouldn't you just say 5? Doesn't square root and squaring kind of cancel each other out?
Yeah.
I can do a different version of that.
Yeah,
Log
they
to
have
the
some,
base
they have a
10
couple of them when they do them weird.
of 10 squared. The log to the base 7 of 7 cubed. 3. 7 to the log to the base 7 of 10 is 10. You see these working together essentially cancel each other out, and the answer is the only piece that's left.
Only piece that's left. That's
When you do logs and exponentials, they are, in mathematics, we consider them inverse functions of each other.
yeah.
That's
I know.
just a fancy way of saying that they cancel each other out. So that's the short way to do those questions.
Yeah, I could
Now,
not.
for some of
figure
them,
out
you could
when it-
actually just do them on your calculator.
Yeah,
but not
those
all
were
of them.
A
For
and
instance,
or
that one.
yeah, they were C and D on number 1, and I was like completely lost. So now that makes more sense. But I didn't get that one. And then there was another one that has, and I think
Okay.
this is just a calculation one. So it has the ln
Okay.
0.93 equals ln x.
Yep.
And I got the other ones done fine,
does?
but C and D were not were not nice to me on these two problems.
Oh, I can do. Yeah. You don't even need your calculator to do this. I'm
'Cause I
going to
put
use a
you-
technique that I use tons of times.
Okay.
As long as you do it to both sides, it's okay. Can't you just cancel
So
the
it
log
would be
from both
no-
sides? 0.93?
So that's how you answer. Oh, because it says X equals already on there. Oh, I missed that part. I'm really glad I asked you because I was starting to feel very hopeless on it. That makes way more sense.
When you're doing a lot of these questions, don't make life difficult. Sometimes it's just a really simple, you know, this cancels that and you've got your answer. You know, like this is 3 and that's 0.93. Look for the more direct, obvious answers
Yeah.
before you start making it really messy and ugly.
Well, and I think I got the first one of those 3 right, but I'm still not sure how I got it because it was the
which one
line
is the
X
first one of
equals
the
4.
3? Say again?
Okay, so the one that I got right was it's the ln x equals 4. And so I did x equals e to the power of 4, which is correct. But when I tried to do that power to or e to the power of what the other ones, it did not work. So I'm
No,
not sure.
this question is not the same as them. Now you say, well, why aren't they? In this question here,
Because isn't
both
ln equal to log to the or log
base
to
E,
the
yes.
base of e?
But in this question here, do you see they both have it? In this question, only one of them has it and the other doesn't. So these questions are quite different.
Oh,
So what
okay,
you did here is not what you need to do up here. I'll give you another one. I don't think. Suppose somebody said to you this.
that makes way more sense.
Wouldn't you just get rid of the e's and solve that?
Yeah.
So I don't need to do anything. If you had told me that the natural log of 2x plus 1 was the natural log of 3, wouldn't I also get rid of the natural logs?
Yeah.
It's only when you do one but not the other that you
I
have to
made
do
that
the hard
so
stuff.
complicated, which was so weird because I was doing the more complicated problems without any issues. And I'm like, I'm pretty sure these are easier because they're the first part of the homework and I could not figure it out. I got it now.
Right. So you were trying to use the technique that you use in the complicated questions on the ones that didn't need that
It
method.
did not need to be complicated.
You could just take an E from both sides or take an log away from both sides and the answer's pretty much finished.
Yes.
Hope you learned something good today. I like that.
I did. That makes I've been looking at those since we did them a few days ago and trying to figure them out.
Gabe, if you got some questions now, I know I gave you plenty of time, maybe more than you were expecting, but have you got some questions or are you good?
No, you're fine.
Oh,
Is it okay if you just go over number 5 in the practice final exam?
number 5 coming up, if I can find it. Okay, now
Sure.
I'm going to zoom down
Thank
to
you.
the solutions, and that way I could maybe talk through what I did instead. If I can find it. Here we go. Make that go away and make that a bit bigger. Question 5, right? Is that the one? Now, these notes were made
Yes.
slightly different. Yeah, from a slightly different textbook. So the formula just looks a little bit different, but it's really not that much different. Right. So this guy called I is basically R over N. That's all it is. And this guy here, A, would be called P. So basically, this formula, the way you would see it, would be M equals P R over N divided by 1 plus R over N to the NT minus 1. So the formula looks different. It's just it's a little bit more compact. That's all it is, right? So I'll write that question down and then I'll show you how you would probably use it in your world, right? The way that we did it in this textbook. And so what have I got? You want to have $100,000. That's P. And the interest rate is 4.2%. So I'm writing that down. And time is 14 years. And somewhere else, oh, you're doing it monthly. So I'm now going to close this guy off and show you what that formula would look like in the way that you would have seen it in your homework. So it would have been M, the monthly amount that you need to pay, P, R over N, and on the bottom, a 1, oops, a bracket, a 1 plus 0.04. Well, I'm putting in the numbers here before we got, so 1 plus R over N to the NT, take away 1. So that's what the formula looks like. Like that's what you would see. So 100,000 goes here. The interest rate as a decimal is 0.042 over number of payments, 12. So that's the top row. Bottom row is going to have 1 plus 0.042 over 12 raised to the power of NT, which in this case is what, 12 times 14. Take away 1. Now, I'm going to be a bit more careful than I was the last time I did one of these kind of questions. So the top is 100,000 times, in brackets, 0.042 divided by 12, close brackets, and I get a nice number, 350. Okay, you can look at that. The bottom one now is a bracket, 1 plus 0.042 divided by 12, close the brackets, raised to the power, put a little bracket in, and do the 12 times 14 years. Close a little bracket, and take away 1. And I got 0.7985. And now I have one last calculation. The top answer divided by the bottom answer. And the answer I got here is $438.32. The answer that you'll see in my review sheet is $438.30. Why am I not exactly the same? I mean, how come I'm a couple of cents out?
I'm not sure.
It's just rounding off. Maybe I should round it
Oh.
off with a little bit more than I did. That's all. So it's not that uncommon that if you round off to 4 decimal places, or you round off to 6, or you round off to 2, the final answer will be out by, it could be as much as a couple of dollars. That's not too big an issue as long as the question isn't too specific. If it just says, you know, give me the answer, then there's a lot of wiggle room. If it says, give me the answer to 3 decimal places, well, for money, it would be to 2 decimal places, right? It's a good idea to do everything to at least 3 or 4 decimal places to make sure that when you round off at the end, you've got a really good answer. So although the final answer might be 2 decimal places, it's a good rule of thumb to do all your calculations with a couple of extra decimal places to be safe. So do the top to 3 or 4, do the bottom to 3 or 4, right? That way that when you finally round off, you're probably going to be pretty much right on top of it. Does that make sense?
Okay.
You do, again, let me emphasize that you do not need to worry.
It does.
That's the guy that you're going to see in the question. You won't see my condensed version. It's the same question, right? It's just slightly different looking letters, and the formula looks different because I'm using A and not some other letters. But it's for all intents and purposes, it is the same question. You just have to know who E and I represent. That was a good question. Have you anybody
yeah.
get any more? We're getting close to the end here. We've got maybe time for one, pushing it,
If
two
no one
more
else
questions. Yeah, what you got? Because nobody else seems to be asking, so
if we can go over number 5 and the multiple choice.
sure. Right, I'll zoom up to number 5, see what we got. Okay, come on, it'd take me forever to scroll up. That's a lot of work when I first did this. Oh, it's a really cool question. I like this question. I like to throw in at least one question that's kind of weird and different. And it's all to do with the fact that I want you to be able to look at something and just see it in a different way. So, which of the following lotteries do you have the best chance of winning? 48 numbers, and you have to get 8 correct. 48 numbers, right? There's 48 numbers in the big, you know what it is, it's those balls, they'll jumble about inside the big drum, and 5 numbers come out, and that's the winning lottery, or 3 numbers come out. Which one of these have you got the best chance of winning? You do not need a calculation. You just need to think it. If you were in, you know, if there were 3 states and each one had one of these lotteries, I know which state I would be betting in. Get 8 correct, get 5 correct, or get 15 correct. Now remember, you have to get all of them correct to win the lottery. Any takers, anybody? Which one?
I have a question.
Yes.
I don't play the lottery, so I don't know how. I don't know, but it says. So is it basically saying that they're rolling 48 balls? Like, is there 48 numbers and you have to get 15 of them correct to possibly get the winner? Okay, that's what I was wondering.
Yes. Now the way it works is that the numbers come out, and you know they do it in TV in some places at least. They bring them out in TV and they put them on a little screen at the front. And this month's lottery number are 17, 18, 22, 50, and 42, right? I don't want to give this answer away. I'd rather somebody said it and it was wrong, and then we can maybe explain why it's wrong, than me just to say, oh, by the way, it's this number. And you'll think, oh, okay, I don't know why, but okay, that's the answer. What do you think's the easiest one to win? 5 numbers, right? So 5 numbers come out and you guessed all of them. 8 numbers came out and you guessed every single one of them. Or 15 numbers come out and you guessed every single one of them. Which one of those is the easiest to get right? Last chance. 5. Well, let's be silly. Getting 1 number right or getting 2 numbers right? Which is easiest? Isn't getting 1
2.
number right easier? No, getting 1 number right. Because all you need to do is pick 1 number out of 48, right? You have a 1 in 48 chance of winning. How many different ways could 2 numbers go out? Well, you might say, well, there's 2 numbers, so I'm more chances of getting them. But think about it, aren't there also even more chances of getting it wrong? You know, if there were just 2 numbers. Let's suppose you pick number 1 and 2. For that to happen, it's 1 out of 48 times 1 out of 47. That's a big number. If you do 5 numbers, it's 1 out of 48 times 1 out of 47 times all the way down. But that's less than any of the other 2. which maybe explain why people who bet lotteries, who don't understand the probabilities behind them, think that an 8-number lottery is better than a 5-number lottery, or for that matter, a 3-number lottery. And I don't do lotteries, but if I was doing lotteries, do you know I'll pick a 3-number lottery over an 8-number lottery any day of the week? Because I'll win. Well, I probably wouldn't, but I have more chance of winning on a 3-number lottery, right, where you only need to pick 3 winners, than in a 5. So that was the answer. It was just 5. It wasn't that you needed a calculation. You just need to have an intuitive idea of what things are more likely to happen compared to similar looking other things. Do you know what the normal numbers in a lottery are? Karen doesn't know because she doesn't do lotteries, but does anybody know what a typical lottery, the Washington State Lottery, for instance, how many numbers? Not one of this, not one of you people do the lottery, obviously. Nadia, have you ever done a lottery?
I'm sorry? Have I been what?
Have you ever bought a lottery ticket?
Just one time, but usually I don't play.
Yeah. Can you remember how many numbers you had on your ticket?
Well, it was 1 or 2 of a combination.
Oh, I don't know, recognize that. I'm not saying that's not a lottery. There are lots of different lotteries. And the going number is 5. Most lotteries have 5 numbers. And the chances of winning a 5-number lottery when there's somewhere between 40 and 50 numbers in the bucket is about 14 million to 1. That's why when people win the lottery, don't they win millions? The chances that you could choose the winning lottery numbers is about 14 million to 1. So probably it's a good idea, Taryn, that you don't do it. And Nadia, you were a good idea that you only did it once and then don't bother, because you probably won't win. Unless you do win, in which case it's totally worth it, isn't it? Because winning, you know, $20 million is not to be scoffed at. Have we got maybe time for one last question? Or
Professor.
are we about?
Yeah, I have a
Yes.
question for homework.
Great. What you got?
Chapter 10.3. I actually had.
Okay, hold that thought.
Okay.
I'm just seeing if I can find it.
Mm.
Do you? Is it an easy question to read out, or will I need to go looking for it?
I actually had 2 questions, but one's easy and one's
Okay.
I'm not really sure.
Well, give me. Is it easy to read the question out? That's all I really need to know.
Oh, okay. I'm not.
Maybe not.
Really sure.
Okay,
No,
I've
it
got
might
them
be
in front of me.
Arabic.
Don't worry. Let me
Okay.
just zoom in and get the questions in. So, what section was it again?
10.3.
And what number in 10.3?
Number 4.
Number 4. So I'm going to look at that one first. And 10.3. Oh, darn it. Go away, those peoples. There you go. And question number 4. Oh, we only have 5 questions. Okay. So in question 4, you have t, and it's equal to 65 e to the power of negative t over 250. That's my version. Yours might have slightly different numbers.
Sorry, you're
And
cutting out. Would you okay if you say that again? Yours.
Yeah, I'll show you on the
Okay,
screen
thank
here.
you.
So you're given this equation, and in my particular one, you're told P is 35 watts. You might be told a different number, but here is the equation. And here is P, and we're being asked to find P. So you write down your guy. This negative T over 250, I do not like fractions. So I'm going to do a 1 over 250. And as a decimal, it becomes negative 0.004 T. That's much easier in my brain than this weird fraction. Now, I know this is 35, and we are going to find T. You remember, as long as you do it to both sides, it's okay rule. What order should I do, or what should I do first, and then what order?
Sorry, how did you get the 0.004 again?
I
Negative
did
0.00.
1 divided by 250 on my calculator. So see when they
Okay,
say
thank you.
negative T over 250.
Mhm.
Another way of looking at that is negative 1 250th T, and then turn that into a decimal. Yeah. Okay, what should we do to both sides to solve this equation?
Divide by 65 by both sides.
Great. So if you divide both sides by 65, you're looking at this guy. And then I'll go 35 divided by 65, and I've got 0.5384. Can you remember the next step? I'm doing a little thing by my hand. I have a nickname for it.
Oh, don't you change to by log E?
Yep. Okay. You're right. I call it the circle of life. So the log to the base E of this guy equals that guy. And the log to the base E is also called ln. And the reason I'm doing that is so that I know which button on my calculator in a few seconds from now we're going to hit. So what do I need to do to both sides to find T?
To divide negative 0.004.
And at this point, I'll go to my calculator and I'll do the natural log of 0.5384, and I'll divide it by negative 0.004. And the answer I'll get is about 100 and, well, I don't know. They might want whole numbers or anything. Can we pretend it's whole numbers, which is it's 155. So that would take 155 years or days or weeks. It depends on the units of time. A lot of the time is in years, but it could be in minutes or seconds, depending on the question. So it's 155, let's say, years in the future,
Thank you.
or 155 seconds for this motor to reach that speed.
So I've done number 5, and I got 1.7782 as my number, and I put in 1.8 for my answer in the homework, but it showed that it was wrong. And I'm not sure if I'm supposed
Okay, so what I need to is this is question 5 from 10.3?
Yes.
Right, I'm going in right now to see what your particular question is, Romy.
Okay.
That way it'll give me an idea of what you have got. And that was question 5. Taking a few seconds to load up. Question 5 is a totally different question. It's the one with log E in it, isn't it?
Yes.
Okay, so what we just did here wasn't that question. So I have to do that as a separate question. We'll see what you got. What number did you say it was going to be again?
I got 1.76.
What answer?
Oh, I put in 1.8.
Okay, so I can see that. You made it 1.8. I can see that now. Okay. The answer is a lot different from that. So I wonder what might have went wrong. So let's show you how we would, I shouldn't have done that. Darn it in space. Do you know what M is? So I don't have to go back out and in because it'll take me forever and a day to do that.
Yes,
For this question 5, what was M?
8.3.
Is that what the number they gave you in the question?
Yes.
Okay, so all I'm doing is that. So log of E is going to be this plus that. So that's pretty straightforward. 11.8 add 1.5 times 8.3. I am looking at 24.25. Did you get something like that?
Yes.
Or maybe that's where it went wrong. Okay, now, when you don't see a number, it means log to base 10. And I'm going to do a circle of life thing. So
Oh, I forgot
10
do
to the
that.
power of, yeah. So you see where you went wrong? That's what you're going to type in as your answer. 10 to the
Oh,
power of 24.25.
I just did the 10 to the power 24.25 and got 1.778, so I decided to round up to make 1.8.
Oh,
And
yeah.
wrong.
Yeah. The calculator probably would kill over and die if you told it to do that. It's a ridiculously ugly answer. So all WebAssign wanted you to do is to write this guy down.
Okay, thank you.
So if you were doing this in a test, it's a really good idea to write that down before you do what you thought you needed to do. Because if I was saying this, I would say she got the right answer. She tried to make the calculator and it keeled over and died on her, and it gave her some silly answer. And because it's such a big calculation, it's just too huge for it. And you'd lose a point. You wouldn't have lost much.
Okay,
So
thank you.
moral of that story, always write down lots and lots of work in. Even if in your homework you don't necessarily do it because it takes you forever to do your homework. Make an exception for the final exam. Every little thing you can write that gives me the opportunity to give you points, I like. But if you don't show me stuff, I can't do it. That's basically it. Okay, guys, I think we've come to the end of our time. Have a nice day. If there's a last minute question and it's relatively quick, we should be able to get it done. So anything else before I say bye-bye? Oh, bye-bye,
Actually,
Gabe.
it's not a question, but I was wondering if you're gonna have office hours.
I'm going to
still?
have office hours at 10 o'clock tomorrow, as I always do. So you can drop in there if you have a question.
We should have it next week.
No, because the final exams, they'll be happening during my office hours in many cases, or tests. I won't be free.
Yes.
So
Okay, thank you.
if you come across some things that you need help, 10 o'clock tomorrow will work.
Yeah,
apart from that, not going to work.
I'm going to have. Okay, thank you.
You can shoot me an email, Romy. If it's something I can answer by email, I will certainly try.
Okay, thank you.
Okay.
I was just
If you
wondering.
do email questions, I know it's kind of obvious, but it isn't. Say question 5, 10.4. If you just say question 5, it's quite hard for me to figure out which question it is. So that's just a little tip.
Yes.
Okay.
Thank you.
Bye-bye. You are welcome.
Yep, have a good day.
You too.